In this example, we're going to find the derivative of the function x to the 6th times 7 raised to the 4x. And I'm going to use logarithmic differentiation for this. So to use logarithmic differentiation, first what I'm going to do is I'm going to take the natural log of both sides of this equation. And then I'm going to use the rules of logarithms to simplify the right-hand side. So I'm going to first use the rule that if I have the natural log of m times n, I can rewrite that as the natural log of m plus the natural log of n. So that's what I'm going to do here. I'm going to think of this is my m and this is my n. So I'm going to rewrite this as the natural log of x to the 6th plus the natural log of 7 raised to the 4x. Then I'm going to use the exponent rule for logarithms, which says if I have, let's say, m to the power of n, if I take the natural log of m to the power of n, that is the same thing as saying n times the natural log of m. This rule tells me I can bring the n down in front of the logarithm. So I'm going to use that rule next. I'm going to bring down the natural log of f of x. So the 6 in the natural log of x to the 6th, I'm going to pull that down in front. So I have 6 natural log of x plus, now I'm going to take the 4x down in front of the natural log of 7. So I have 4x times the natural log of 7. Now, you don't have to do this, but I like to do it. I have a preference about keeping my coefficients in front of my x. So I'm going to rewrite this, although I don't have to. Remember, this is just some value. It's a constant. And this is a constant. My x is the variable. So I'm going to rewrite this, I'm just going to reorder this so that my coefficient's in front. So I have 4 times the natural log of 7 times x. This is my coefficient for x. Okay, now that I have this all expanded, I'm going to now take the derivative. So when I take the derivative of the natural log of f of x, I'm going to have 1 over f of x times the derivative of f of x using the chain rule. And that's equal to, now when I take the derivative of 6 natural log of x, that gives me 6 over x, because the natural log of x has a derivative of 1 over x, and then I still multiply that by 6. And now, when I take the derivative of 4 times the natural log of 7 times x, I keep my coefficient, and I take 1, which is the exponent, using the power rule, 1 times 4 times the natural log of 7, and then that becomes x to the 0, which is 1. Just like if I gave you 5x, and I said, what's the derivative of 5x? You would say it's 5, because you're looking at just the coefficient in front. Well, that's why when I take the derivative of 4 natural log 7x, it's just 4 natural log 7. Okay, now the last thing I need to do is isolate my f prime. So I have 6 over x plus 4 natural log 7 times my f of x, because I multiply both sides by f of x to clear this here. So I'm just multiplying both sides by f of x like this. So then these disappear. Now, f of x, that was the function that we started with, which was x to the 6th times 7 raised to the power of 4x. I can leave it like this, but if you want to continue simplifying it, all you would have to do is distribute the x to the 6th times the 7 to the 4x. So I would take this times this, and then this times this. Not leaving myself enough room. Let me make some more room. So when I take 6 over x times x to the 6th, 7 4x, I have 6x to the 5th times 7 to the 4x, because this x here would cancel with one of these x's, so I'm left with x to the 5th, plus I would have 4 natural log of 7, which is just a constant, times x to the 6th, 7 to the 4x. So if you want to expand it, you can, but leaving it like this is also perfectly fine.